So we've learned about creating variables using variable declarations. We've learned how to assign values to variables using the assignment operator. And then we've learned how we can access that variable once all that's been done. Now we've learned all that in the context of the int data type, which is for holding whole numbers. Now there's another type of number we need to learn about, which is the floating point number, or as it's called in math, the real number. Now, a floating point number is a number that has a decimal point, and then it has one or more digits to the left of that, and one or more digits to the right of the decimal point. The data type that we're going to use, the one that we're going to concentrate on for now, that can handle floating point values is going to be the double. So when we do a variable declaration for a double, we're going to start, as always, by declaring the data type. So double is going to be the keyword that we write for that. Now double can hold negative floating point values, it can hold positive floating point values, and it can also hold 0. So once we've got the data type, next we need the name for the variable. And I'm going to call this pi, and it's going to represent the mathematical value pi. Now that is a valid variable declaration. So far it looks just like we did with integer variables, we just use a different keyword. Now we know that once it's been declared, I can come down and I can do an assignment, just like I did with integers. So I can do something like that. Or I could do a single statement, combine this, and initialize it as I declare the variable, just like that. Now we know that below that, anywhere below that, as long as we stay in main, we can access that variable, and we could do something like, say, this, where I print out the value pi. There's other things that we can do with it as well. If I go ahead and compile this, we can see what happens. And we see it prints out 3.14, just as we expected. Let's do an experiment here. Let's take double out and put int in its place. So I'm declaring pi to be an integer variable this time. Now, immediately we're alerted to a problem. Visual Studio tells us. We see by the red squiggly here. If I hover over it for just a second, it will tell me the error message, which is cannot implicitly convert type double to int. Implicit is a very important word in programming. Basically it means automatic. So what it's telling me is C# cannot automatically convert 3.14 into something that will fit into an int. It's kind of like an int is a box that's of a certain size, and it's just big enough to hold a whole number. So in this case, it's just big enough to hold the 3 out of 3.14. It can't handle the decimal point or the 1/4. For that, we need a double. So a double is like a box that's a little bit bigger, and it can handle all the components of a floating point number. So it's just a little bit bigger than the int box. So we go ahead and put this back, and now everything is good to go. Now this code we saw when we looked at declaring integer variables. So here I'm declaring 3 separate integer variables, and then I'm doing an assignment and printing out the value of sum. If I decide that I want this to handle more than just whole numbers, then I can change it so it will also handle floats by doing this. I just take int and change it to double, and that's all. Now it's ready to handle floats. It's just that easy. I don't have to change anything else. Now, one thing to point out about operand 1 and 2 is they're assigned values that are written as integers. So 4 and 2, as written here, are integers. Now I could change them to floating point values by doing this. Just add a 0.0 to the end. It doesn't look very good. I can leave it like this. C# doesn't mind, okay? It doesn't mind that I'm putting an int in a double because an int fits inside of a double. Remember, it's just that whole number part. A double can handle the whole number and then some. So a double can hold both ints and it can hold floating point values. It's just the reverse that doesn't work. I can't put a floating point value inside of an int. So now you may be wondering, well, if doubles can hold both ints and doubles, why use integer variables at all? The answer is computers love integers. Integers are very easy for computers to deal with. Floating point values like doubles, have overhead associated with them. So it takes more processing. It's more complicated. So the rule of thumb is if you're going to be dealing with data that is just going to have whole numbers, we can use int for that. If there's any chance that we're going to be dealing with something involving floating point values, then we can use double for that. In this example, we see that we can combine data types in a program. Here, I've declared number of books as an int. Now, looking at the name number of books, that's how I chose int, because I'm going to be dealing with whole books. I mean, I'm not going to be dealing with ripped up books, partial books. I'm going to be dealing with whole books. So int makes sense in this case. When I look at these variables here that are declared as doubles, price and total cost, that says to me, money. So for instance, if I'm dealing with US currency, price could be $7.99. So there's a good chance there's going to be a cents component to the money. So I'm going to use double. Now in this line down here, I'm doing an assignment. To total cost, I'm assigning the result of the expression on the right. So what's going on here? I got two things that I'm multiplying together. Asterisk is multiplication in C#, and it works just like you expect. So what I'm going to do is I'm going to take the value and number of books and multiply it by the value and price. But what about the data types? Number of books is an int and price is a double. That's okay. We can do that. No problem. Now what's going to happen is when I multiply an int and a double, I'm going to wind up with a double. Because when I do expressions that put ints and doubles together, it's like double takes precedent over int. If I multiply an int by an int, I get an int. If I multiply a double by a double, I get a double. It makes sense. But when I do an int times a double, I wind up with a double because double takes precedence. If we print this out, or compile it rather, and we see that it prints out the message based on this, total book cost $79.9. Now that's supposed to be $79.90. We don't see the zero. We can fix that. We're going to use a format specifier to do this. A format specifier is what it sounds like. It's something that allows us to specify the format that we want a value to appear. So I'm going to use the F format specifier. First of all, let's come down here. And after total cost, since it's what I want to format, I want to put a colon. So that's how I'm going to start it. And then I'm going to do F. F is the format specifier for floating point values, which total cost is. Next, I'm going to put a 2. And the reason why I chose 2 here is because I want to print out to 2 decimal places of precision. I want 2 numbers to appear after the decimal point. If I put 3, it's going to do 3 decimal places. If I do 4, 4, and so on and so forth. If I have a value that has more digits to the right of the decimal than 2, then it will be rounded up. Let's do one other thing first too. Let's put a $sign here so that'll print out on the console before the number and look even better. Let's go ahead and compile it. And this is what we see. $79.90, just like we wanted. Now, since we're dealing with money, there's actually an even better way of doing this. Let's get rid of this $sign. And let's get rid of the F2. Leave the colon, because we need that. And I'm going to put C. C is the format specifier for currency. And it's going to print this as currency based on the currency of the machine. Whatever country the machine is set to be in is what that's, it's going to print it out as. So for me, it's going to print it out with a $sign and 2 decimal places. So if I press start to compile it, we see that it prints out just as before, except just using that format specifier. Now, that's all we need to know about doubles for now. We'll actually see more when we talk about mathematical expressions, and we'll also learn about other data types later that can hold floating point values.